The person who invented this large fan is truly a genius. It uses 5 kilowatt-hours per rotation, providing a continuous supply of free wind. So how exactly does it generate electricity? Firstly, the blades are the most crucial part of a wind turbine. Typically, there are 3 blades to balance stability and efficiency, and they are designed aerodynamically, similar to airplane wings. When the wind blows over the blades, aerodynamic principles create lift, causing the blades to rotate. The longer the blades, the stronger their ability to capture wind, which directly affects the power generation capacity. The rotation of the blades drives the main shaft to rotate at a low speed, approximately 10 to 20 revolutions per minute. However, this speed is not sufficient to directly drive the generator to produce electricity, so a gearbox is needed to increase the speed. The gearbox typically uses a multi-stage planetary gear structure to gradually increase the torque, ultimately reaching the high rotational speed required by the generator, usually between 1000 to 1800 revolutions per minute, thereby generating electricity. However, this type of wind turbine has a drawback. Over time, the gearbox is prone to damage, and the maintenance costs are very high. Therefore, many wind turbines today, especially offshore wind turbines, no longer use gearboxes, but instead have the main shaft directly drive the generator. However, it requires replacing the doubly fed wind turbine with a permanent magnet synchronous wind turbine, which increases the output frequency by enlarging the generator's diameter and increasing the number of its magnetic poles. But it also has disadvantages that it generates variable AC, which requires the use of a converter to convert the variable AC into DC and then into 50 Hz AC before it can finally be stepped up by a transformer and integrated into the grid. This process results in high power loss. Additionally, manufacturing permanent magnet materials requires many rare earth elements, which makes the cost very high. Fortunately, our country controls 90% of the global supply of rare earth elements. But there is another issue, which is that wind speed and direction are very unstable. So how do wind turbines adapt to changes in wind direction, control their speed, and achieve stable power supply? Before answering, if you also enjoy watching interesting and in-depth science videos, I highly recommend you check out Douyin Select. This is a high-quality video platform launched by Douyin, gathering premium video content here, along with a vast collection of high-rated quality documentaries, ensuring every minute of your time is fulfilling and satisfying. If you love high-quality videos, don't miss it. It turns out that each wind turbine is equipped with a yaw system, which can detect changes in wind speed and direction in real time and transmit the data to the control system. The control system analyzes the wind direction deviation, calculates the necessary adjustment angle, and then controls the yaw motor to drive the turbine to rotate around the tower, ensuring the blades always face the wind. Additionally, the blades have a pitch control system, which increases the angle of the blades facing the wind when the wind speed is low, allowing the turbine to capture as much wind energy as possible. Conversely, when the wind speed is high, the angle of the blades facing the wind is reduced to decrease the rotation speed and prevent damage to the turbine. However, in extreme wind speeds, the blades will rotate to a position completely parallel to the wind direction, allowing the wind to pass directly through the blades, thereby completely stopping their rotation. Otherwise, the blades are likely to be damaged. Generally, for a 5 megawatt turbine, each rotation can generate about 5 kilowatt hours of electricity on average, while for a 15 megawatt super large turbine, each rotation can produce more than 20 kilowatt hours.